some fun factoring. All right. Oh no, it's not a quadratic, is it?
No.
What is that?
It's what the degree of this expression is 6, isn't it? It is a trinomial, but it's not a quadratic trinomial.
It's
But we do want to factor it. What is always step 1 for factoring? Yeah, what is it?
X squared.
Let's pull it out.
Is this a you try?
Not yet.
Well.
So literally, like, none of this stuff is gonna be on our exam from now on.
Wait, so why are we doing
No. This is junior level math, isn't
Good
it?
stuff, right?
Yeah, like,
Hmm.
weird, like, we're not just
Okay, so when I factor this out, I get x to the 4th minus 14x squared plus 49.
Are we gonna do factoring?
Who just recognized a special type? I saw it. Who else?
I know.
Who else?
I
Keep
did.
looking. Oh, you see it? Good.
saw
Good.
it.
Minus.
Raise your
Ah, you see it?
Yeah, I don't know.
Is it the
Ah, she sees it. Yes. Got it. All right. Oh, yes. Many of your classmates looked at this and saw a perfect square trinomial, which can be written as a
Difference of squares.
binomial
Square.
square.
They're very close. Good job.
Oh, I see.
Oh.
That was nice and easy.
Sorry.
It looks funny, but
Now, this is completely factored over the set of integers. And that's how we factored so far. We have completely factored things over the set of integers. Eventually, we're going to completely factor over the set of complex. Dun, dun, dun. Not yet. We're sticking with integers right now. Okay, so this is completely factored over the set of integers. I'm going to give you guys a chance to see how far you can get with number 2. It's a little different. It's a little different. And a little the same.
The pride of Macy.
Let's see what you can do with number 2.
I know. Still hard.
Yes.
Did your kids ever watch the Wiggles?
I actually was listening to your conversation and almost joined in, but refrained.
I used to love
The very first concert my daughter ever went to.
Was it Wiggles?
Me too.
Yeah. I've never been to one. Well, actually, I went to a Kiss. That's it. Oh, Kiss culture as a kid.
And then her next concert was supposed to be Taylor Swift.
What happened to that?
And then, well, they postponed the concert. She got sick during the summer when it was supposed to happen.
My sister went to that one.
And so they moved it. And so her first other concert was Selena Gomez.
I think there's better.
All right. Take out the 5x.
What?
I mean, x to the 5th, not 5x. X to the 5th.
I did not know you could do that.
Yeah, I did. Or,
I thought she would have like.
All right.
I thought it happened like I didn't know.
Now, this is not a perfect square trinomial,
No.
but it's in quadratic form. Do you notice this is quadratic form?
Yeah.
It's x to the 4th that's being squared.
Yes.
Do y'all see that? So,
yeah.
so if I wanted to use what they call in math in substitution, let's say I let n represent x to the 4th. Could I rewrite this line right here? I'm going to change colors just because I'm just doing this line. Could I rewrite this as n squared minus 15n minus 16?
What?
I
Are you gonna change colors?
Would you just set it up?
I will. I'm sorry. Because you can't see that one.
Oh wait, did you change colors?
Wow.
I did.
Oh.
Oh,
There.
that can say pink.
Is that better?
Oh, yeah.
Okay. Sorry.
What?
Do you keep
Okay.
X?
Now, I do not have to do that. But you can think about it this way. You can think of this being in a quadratic form. If we let n represent x to the 4th, isn't x to the 4th squared x to the 8th? And 15, if we substitute back in x to the 4th, same thing. Now, would you be able to factor this easily?
Yeah.
Yes.
Wait.
Okay. So what did I let n substitute in for? X to the 4th. So this is x to the 4th minus 16 times x to the 4th plus 1. And there was that x to the 5th out front.
But you can still write it.
Okay, now, those of you that didn't like the n substitution, fine, don't do it. Go straight from here to here. That's what I do. I go straight from this line to this line. But if you need to be able to visualize it in quadratic form, and the n substitution helps you, do
X
it.
squared, you just do XX, so you just
Mhm,
basically
mhm.
do the same thing.
Yep.
Yeah.
Yep.
I like that first one.
So,
It's not always x to the 4th though.
Am I? No,
It's just whatever like
no.
minus a common factor. That's
Right.
Okay.
Yes, Bridget.
okay, so two things. One thing, I did it a completely different way. I didn't pull out x to the 5th, but I got the same factors. Like, but I didn't pull out x to the 5th.
Okay, we always want to take the GCF out first.
Okay, and then if you wanted to keep the n, would you just like the last step would just be convert it back,
Yeah.
like not leave it in n form?
Exactly.
Okay.
Now, who is still not happy with this problem? Oh, this is a difference of squares, isn't it?
Oh my.
All right, let's keep going then. What would this factor here?
X squared plus
Which factor is even more?
Which factor some more? See, we're back to fun factoring.
Oh my.
What is that?
I was so excited about writing my smiley face that it ended up looking stupid.
You should draw it here on one of the eyes.
Oh my gosh.
All right, now, at this point, it is completely factored over the set of integers. Now, if we completely factored it, if we did the complete linear factorization, we would get some complex factors, which we're going to do, but not yet. So this is completely factored over the set of integers. Yes. All right.
Hold on 1 second.
So it's completely factored.
This is completely factored.
There's no surprise.
Look, there's no. Look, I ran out of space.
That's a
I have to
smiley
be done.
face.
You could click that double arrow.
I could, but I don't need to. I'm done.
Wait, was that supposed to be a smiley face or an arrow?
This is a smiley
one
face.
below.
Oh, the one below
Be a
it.
frowny face.
Oh, that's an arrow.
Okay.
So this is smiley face. Clearly.
Yeah.
See, there we go.
That's lit. I like it.
What?
I like the first one.
This will be used sideways so they're like fits into
This
the
is the one
problem.
I opened.
All right. Has everybody had a chance to copy that down that wanted to? Great.
That's really weird.
All right. Uh-oh. Different.
There you go.
All right. Is there a GCF?
Nope.
No. So, some of you asked about this earlier.
I believe.
It's 4 terms.
Yeah.
Oh,
You
so
split.
splitting.
I
We try term splitting. Yes, we do.
I don't remember how to do
Try.
that.
Let's go, Ian.
Yeah.
Learning for understanding.
You don't remember? Okay. So we're gonna try term splitting. So what we do is we look at the first two terms, and then we look at the second two terms. So when we look at the first two terms, do the first two terms have a GCF?
That works in school.
Yes, it's a 2x squared. And when we factor that out, what are we left with?
This will be, you can't do 2x.
It should be
So you can't do 2. You're right. Just x squared. Thank you. So we're left with 2x
Plus 1.
plus 1. Okay, so to do term splitting, we want these two to match. So over here, we want 2x plus 1.
And then you pull out 36.
So what do we factor out of here?
Negative 36.
Negative 36. So that gives me 2x plus 1 times x squared minus 36. Not done.
Because the 36
Yes.
and then the x squared.
Because this is a difference of squares.
Wait,
X
where did you get
minus
that
6,
from?
x plus 6.
Wait, where's that 36?
Wait, what happened to the next square?
Because 36
Yeah.
should be
Okay.
Can you re-explain?
I sure can.
Wait, shouldn't it
2x
be
minus
squared over
36.
2x squared?
Wait, are you
gonna pull the x squared
You
down?
combine
You have to combine the
Or did it disappear?
x squared on the.
All right.
Oh, it's both 2x plus. Okay.
Okay, so, you guys were good. Woo! Wrong thing.
Bye bye.
You guys were good with that, right?
Yeah.
Okay, so this is how we did, we called it term splitting, and we factored by grouping. We group the first two, we group the second two, we pull out what they have in common, and then the binomials that we have left are the same. Well, whenever we have two terms that have a common factor, both of these have a common factor of 2x plus 1, 2x plus 1. Don't both of these terms have that as a common factor? So I can factor out that common factor. When I pull out the 2x plus 1, what am I left with? An x squared and a minus 36. X squared minus 36.
Oh.
So when you pull out the common factor, you group what's left. You group this and this. And so that x squared minus 36 factors to x plus 6 times x minus 6.
Would it not be 2x plus 1 squared since there's 2 of them?
Oh, I see.
No.
No, because these are two terms and we're pulling out what those two terms have in common. This term and this term have this in common.
Okay.
So
Because, okay, watch this. If I were to distribute this back, wouldn't I do this times that, x squared times that? Isn't that what I had right here?
Okay.
And wouldn't I do negative 36 times that, which is what I have up there? Okay. All right, you try.
Whoa, there is a just.
Term splitting is easier than I remember it being the first time.
no, it was easy. It's just
Yeah, it's just been a while.
no, I'm not trying to solve these. I
Got it.
get the
Got
try.
it. Yeah.
Got an idea of going with it.
So this is.
Oh, yeah.
Did you get this?
No, you just leave 3 all the way out. Just forget about that.
Would you keep parentheses around the whole thing on your grades? Oh, no, you wouldn't. Oh, yeah, I forgot. Why wouldn't you keep it to my override completely?
Wait,
Aww.
why did you pull out x squared?
Hold on.
Pull out 6.
Because you have to.
I did.
Well, hold on.
It was a great answer.
You're making 6. I made my own Roman.
Yeah.
But I just did my
Okay, so you do like that 3 completely.
But I'm gonna get the same answer. Hold on.
Multiplying all the way across, right? Don't you have to keep your 3s separated?
Yeah, I added an additional.
That's what I did.
Yeah, but you left the parentheses up.
It's a
Yeah,
GCF.
within a
It's a GCF.
That's what
I wasn't sure
It's a
if
GCF.
Or is it squared plus 6 be factored?
It's GCF.
Wait, why would you keep the 3 outside? Because it starts to be outside, and it's just stay on the outside.
It's a mouse.
I get that?
That's what I have. That's where I'm at.
I actually did it. Right. Why'd you do that?
Yeah.
Most part of the whole thing, like, no,
Alright.
I'm gonna get it.
I've seen most of you go, oh. So do we all get it?
Yeah.
Alright. Okay, the fun continues. So those are different ways to approach higher degree polynomials. That's a different way to approach higher degree polynomials. What we're going to look at now are cubics. Specifically, a sum and difference of perfect cubes.
What?
I'm going to flip the page in just a second, but some people were talking while the rest of you were writing down the correct answer to the last one. And then they needed me to go back. So we're waiting on it.
What? What?
All right. So, we're going to look at factoring a sum and a difference of cubes. So this is new. Everything else kind of tied into something we'd already done. This is a new factoring. And this is one of the few times where I'm just going to say, okay, guys, this is how it is. Usually we discover and we prove, and y'all love that part. I know it's your favorite part. But this time I'm just going to say this is how a sum of cubes factors.
Honestly, that's just like, that's honestly better.
I know a lot of people like that better, but...
That doesn't sound right.
Okay, when we factor a sum of cubes, the cubed root goes here, and the cubed root goes here. So if it's a cubed and b cubed, it's a and b. And if it's a sum here. And then whatever the cubed root was, what was being cubed, we square that, and then you do minus the product of the two, a times b, and then you square the last one. So here's our pattern. And the first time I ever say anything, I don't expect you to completely understand it, all of you that went, what? Okay. So the pattern goes like this. If it's a sum, our signs look like this. Plus, minus, plus. Got it? All right. And then what goes here and here every time are the cube roots. So the cube root of the first one goes here. The cube root of the last one goes here. Okay. And then every time the square of this first one, the square goes here. Actually, the arrow should be pointing the other way. There we go. Every time the product of the two goes here, a times b.
If it's a minus, it goes minus, minus, plus, minus.
I'm about to do minus in a second. And then the last one is always the square of the last one. And that's how it goes every time. Now, if I were to distribute this a back through and then distribute the b back through, everything would cancel except a cubed plus b cubed. And feel free to do that on your own if you need that intellectual justification. All right. So, when it's a sum, the first thing I always do is set up the signs. Because once I set up the pattern for my signs, then I don't have to worry about signs. Okay, what is the cubed root of x cubed?
X.
X. What is the cubed root of 125? 5.
Wow.
Okay, then right here is the square of the first one. So the first term is x. So this would be x squared. Right here is the product of the two. X times 5 is 5x. And we don't have to worry about the signs. We already fixed those. And then at the end is the square of the last one. What's the square of 5? 25. It's not double, it's just the product.
I can't wait till it gets really complex.
Okay? And that's how you factor a sum of cubes.
There's to be a higher
that's
level,
all.
so it's not going to get.
Alright, so now let's look at a difference. It's exactly the same except for the pattern of the signs. When we have a difference, this is a difference. So, instead of being plus here, it's minus. And then these two are plus plus. Either way, there's only one negative. If it's a difference, that negative comes first. If it's a sum, the negative's in the middle.
Some comes second.
I like it. Alright, so you guys know what goes here. What goes here? A. What goes here? B. A squared. AB. B squared. Cool. Alright, is 27x to the 6th a perfect cube? Yes, because 27 is 3 cubed, right? And x to the 6th is what? X squared. Is negative 8 a perfect cube? Yeah, it's 2 cubed, right? Or negative 2 cubed. Alright, so let's set up my signs so I don't have to worry about them. Minus, plus, plus. So what did we just decide the cubed root of 27x to the 6 is? 3x squared. And the cubed root of 8? 2. So if I square this first one, 9x to the 4th. Beautiful. If I do the product of these two, and once again, I've already taken care of my sign, so I don't have to worry about that. The product of 3x squared times 2 is 6x squared. And then I square the last one. 2 squared is 4. That's how we factor a difference of cubes. And we're done. Okay, you have a worksheet for homework?
Worksheets.
And let me pass that out.
I like worksheets better than textbooks.
All right.
But, you know.